So for question 6, it's to find the integral of x cubed times the square root of 1 minus x squared dx. Now this problem is just trigonometric substitution, and 1 minus x squared has its own formula to keep in mind. So we're going to substitute x equals sine theta, and dx, the derivative is going to be cosine d theta, d theta. So now we're ready to put it in our integral. So x cubed will be sine cubed theta times the square root of 1 minus sine squared theta, and the dx is equal to cos o do, so times cosine o do. Now, remember that cos squared x plus sine squared x equals 1. So cosine squared x equals 1 minus sine squared x. So we're going to put cosine squared x into that integral to get rid of that 1 minus sine squared x. Now, the square root of cosine squared o is just cosine o. So we're going to write it again. Now, cosine times cosine is going to equal cosine squared. So sine cubed times cosine squared o theta. Now, we're ready to do more trigonometry substitutions. So, since this is odd, we are going to do sine squared o times sine o cos squared o d theta. And we're going to use this same equation, except we're going to do sine squared theta equals 1 minus cosine squared theta. So we're going to put that in instead of the sine squared to make it 1 minus cosine squared theta sine theta cosine squared theta o do. And now we're going to do more substitution and make it so u equals cosine theta, and du, the derivative, will just be negative sine theta, because the derivative of cosine is negative sine. So we're going to get rid of this negative and put it over here so we can keep it constant and put it into the equation. Now, we can't forget about this negative. We're going to put it outside of the integral, and the cosine is u, so 1 minus cosine squared will be u squared. Sine, that's going to go with our do, so we have sine o do right here. And cosine squared is going to be u squared du. So that is further simplified, and now we're going to distribute. So u squared minus u fourth du. And now we're going to integrate. Remember this negative out here, right? So u cubed over 3 minus u to the 5th over 5. And this negative we're going to distribute in now that we're done integrating. Negative u cubed over 3 plus u5 to the 5th over 5. And now we're going to put our original u back in. We're going to put it all back together. So this will go to cosine to the 5 theta over 5 minus cosine to the cube theta over 3. We're not done because it needs to be in terms of x and it's in terms of theta. To do this, we're going to use the Pythagorean theorem and draw a triangle. Now remember, the hypotenuse is c squared, so this is c, a, b. The hypotenuse, so it's c squared equals a squared plus b squared, which would mean that c equals the square root of a squared plus b squared. Make sense? All right, and we're going to go back to the original substitution, x equals sine o. Now remember, if there's no number in front of this, this is just going to be 1, which means that x over 1 equals sine theta. And sine, in SOHCAHTOA, remember that, equals opposite over hypotenuse. So our opposite, this is our theta right here, is going to be x, opposite of theta, and 1 is our hypotenuse, which is going to be here. And this equation will say that this is c squared and this is b squared. C squared minus b squared equals a squared. So a will equal c squared minus b squared in the square root, right? So this is c squared. So this will equal 1 minus x squared. Now looking closer at this, we see that we need cosine to substitute the theta back in. Now cosine equals adjacent over hypotenuse. And this is the adjacent and this is the hypotenuse. So cosine equals 1 minus x squared over 1. And now we're going to put that back in to our equation. So cosine 5 theta over 5, we're going to put that cosine in, and it's going to be the square root of 1 minus x squared over 1 times 5, which is just 5, minus cosine, this has an exponent to the 5, remember, because this is right here. And then we're going to plug this back in, cubed over 3. And this is our final answer.